Hello coders, welcome to my channel. I am Aniket and today we will discuss question from GFG, that is ways to increase LCS by 1. Let's read the problem. Given two strings S1 and S2 consisting of lowercase English letters of length N1 and N2 respectively. Find the number of ways to insert exactly one character into string S1 such that the length of the longest common subsequence of both strings increases by exactly 1. So let's see this with a test case. So there are two strings S1 and S2 of length. First string length is 4 and second string length is 3. So if you find the length of LCS, that is nothing but 2. And what is that LCS? LCS is AB. AB subsequence is common in S1 also and S2 also. That is this AB and this AB. Now if you insert C character here in between of AB and AB, so you will find that your LCS become increased by 1. Similarly, if you insert C in between of A and B, then also your LCS increases by 1, because initial LCS is 2 and now the new LCS is 3. So you have to return the number of ways in which you have insert a new character into the string S1 such that your LCS increases by 1. I hope you understand it, and in this case there are three ways to insert a new character into S1 string such that your LCS increases by 1. I hope you understand the question now. Now let's discuss the solution for this problem. So first we have to understand what is LCS. What is LCS and how can I find it easily? So LCS is nothing but longest common subsequence which is common in both string S1 and S2. So how can I find it? How can we find it? So let's discuss it. To find the length of LCS easily, we have to use DP concept. We have to use DP to find the length of LCS. So what are the parameters for this DP? What are the parameters for this DP? What are the parameters for DP? So the important parameter is, first parameter is ID1 and the second parameter is ID2. ID1 denotes the index of string 1 and ID2 denotes the index of string 2. Now let's discuss the transition diagram. So how the transition goes. So how the transition comes. So let's say your initial state is ID1 comma ID2, and there are two possibilities. First is match, character are matching, and second is character are not matching. Like in this case above, let's say you have an string A, B, E, F, C, and another string is C, B, A, F, G. So if you call your recurrence from 0 comma 0, it is easily seen that 0 character is not matching. But somehow when you reach at one index, then you will see that the one character is matching. So there are two possibilities: first matching character and the second is not matching character. So let's see the matching character case first. So the transition goes from id1 comma id2 to id1 plus 1 comma id2 plus 1, which is easily seen that you will increment from id1 to id1 plus 1 in string s1 and id2 to id2 plus 1 in string s2. because the character are matching. So that's why your LCS is increased by 1 also. So I hope you understand this transition easily. When there is no match in the character, so what is the transition? So there are two possibilities. Either move ID1 or move ID2. We have to do this because we want to generate all type of subsequences. To generate all possible subsequences subsequences That's why we have to go move id1 also, and keeping id2 constant, and another case is move id2 but keeping id1 constant. So the next transition is id1 plus 1 comma id2 remain as it is, and the second transition is id1 comma id2 plus 1. In this case id2 incremented by 1 but id1 remain as it is. Since you want to find the maximum length, because LCS is returning you the maximum common subsequence, so that's why you have to find the maximum out of these possibilities. Let's say this is case 1 and this is case 2, so you have to return maximum of case 1 comma case 2 to get your correct answer. Now question arises that what is the meaning of dp id1 comma id2? What is the meaning of dp1 for what is the meaning of dp of id1 and id2? So the meaning of this is simple. So the meaning of this is what is it is denoting the length of LCS till id1 of s1 and till id2 of s2. It is easily seen. Or you can say it is denoting the length of LCS in string s1 0 to id1 and in string s2 0 to id2. What is the length of LCS? I hope you understand the meaning of dp id1 comma id2. That's why it is giving you answer when id1 reaches to n minus 1 and id2 reaches to m minus 1. So it will give the whole answer, that is 0 to string s1 0 to n minus 1 and string s2 0 to m minus 1. What is the length of LCS? I hope you understand the meaning of dp id1 comma id2. Now question arises that how can we how can we use the basic concept of LCS into our question, because our question is different from this. So how can we apply our basic concept of LCS into our question? Because you are allowed to insert only one character, because we are allowed to insert only one character, so our problem is independent for left and right part. So our problem is is independent for left and right part. So let's say your string is this length and you insert a character here and this length as left. So this is a right string and this is left string and you insert a character in between. So the left part is independent from the right part. So if you somehow find the LCS of left part and find the LCS of right part and plus 1 in between of it, and it is equal to initial LCS, or you can say original LCS plus 1, then you find a way to insert a character such that your LCS increases by 1. Now most of you think is, why I take this plus 1? Does it guarantee also, does it always guarantee you that your LCS increases by 1 if you insert a character? So what is my question? My question is, does it guarantee that inserting a character increases the LCS? So the answer to this question is yes. It always guarantee that it is always guarantee that our LCS our LCS is increased. It is not sure that it will reaches to original LCS plus 1, but it is increased because we only insert relevant characters, not a random character. We only insert a relevant character. Let's say the string is given to you A, B, C, and the another string is given to you A, C, D, and let's say this is the string S1 and this is a string S2. So to make your LCS increases by 1, so what character you insert here? You insert this character, not any random character. So that's why your LCS increases by 1. That is ACD in S1 and ACD in S2 also. Let's see other placement case also. So let's say you are at in between of this in between of this character. So the index is ID1 is this character and ID2 is this character. So this is ID2 and this is ID1, and you decide to insert in between this. So which character you try to insert? Because till this the LCS is 1 because only one character is common in S1 and S2 in this part, and in this part there is no character common character. So that's why the LCS of left is 1 and the LCS of right is 0. So which character you want to insert at ID1? So you don't need to insert any random character. We insert character C only. That is nothing but character C only. That is nothing but S2 dot char at ID2. I hope you understand it. So that's why it is guarantee you that your LCS of left plus 1 plus LCS of right, that is LCS of left and LCS of right sum will increase by 1 by inserting a character. So now if you insert a character C in between of AB, so you will find that your LCS of left increases by 1 and your LCS of right is remain as it is. So that's why your LCS increases by 1 effectively, but it is not equal to original LCS plus 1. So that's why you will not increment your answer, because in this case we only got 2 and your original LCS is also 2, that is AC and AC. I hope you understand the intuition. Now the new question arises that how can we find LCS of right part, because it is easily seen that you can easily find the LCS of left part, but how can you find the LCS of right part? It is not that difficult because it is similar to the LCS of left part. So to find the LCS of right part, we should fill our new DP table. We should fill our new DP table from n minus 1 character of S1 and m minus 1 character of S2. So what I mean that we process our string from right to left to find the LCS of right. Now we have the complete intuition of this problem. Let's jump to the code. But before that, please hit the like and subscribe button so that it will motivate me to create such kind of intuitive video for you. Now let's discuss the code. So here is my simple Java code for the given problem. So this is a function ways to increase LCS by 1 and the input is string S1 and S2. And the n is representing the length of string S1 and m is representing the length of string S2. And similarly, as I discussed before in the transition diagram, if the character are matching, so you have to increase your LCS by 1 and go to the next character, that is I minus 1 and m minus 1, because in this case you traverse from 0 to n or m, so that's why you will see the previous character only. In the transition diagram, we have discussed we have discussed the recursive method transition, but this is a tabulation method. So the plus 1 is replaced by minus 1 in this tabulation method and nothing else. So now if the character is not matching, you have to take the maximum of two possibilities, that is going to previous and keeping the j constant and going to previous and keeping the I constant. I hope you understand this transition now. And similarly you will fill your suffix 2D matrix also, which is representing the process from right to left. So the prefix array denoting the process of left to right and the suffix array is denoting the process from right to left, and both of them are very similar in nature, symmetric in nature. Now this pref of n comma m will store the original LCS, and this is our answer, and we will increment it if we find that LCS of left plus 1 plus LCS of right is equal to original plus 1. In that case only we will increment our answer. Because we want to insert character in string S1, so string S1 is of length n, let's say n is 5, so we have n plus 1 inserting positions. So that's why we will try all types of placement in between of this string S1. And the relevant character, that is s2 dot caret j, that as I discussed before also why it is relevant, and it increases our LCS of left plus LCS of right by 1. And if you find that your pref of position of pos j and the suffix plus 1 is equal to the original LCS plus 1, so you will increment your answer. And most of you think now why I use this additional visited set to track that we don't add the scene characters into our string more than once. So let's discuss this with a test case. Now let's say your string s2 contains duplicate characters. So the character c will inserted same character more than one time. So that's why your answer will increment by more. So the correct answer, let's say correct answer is x. So if you don't use this visited type of set, so your answer, so your incorrect answer will be more than this correct answer, because you will count same character placement two different, because you will count same character placement, because you will count same character placement that you have already placed, you have already placed in past as different way. So that's why you will increment your answer, and finally your answer is more than the correct answer. So that's why we use this visited character, visited set, which is your type character, which means that if you process a character c, so don't process it again, because it will unnecessarily increment your correct answer. So in this way, finally you will return your answer. I hope you understand my code and the intuition behind this code. Please hit the like and subscribe button so that it will motivate me to create such kind of intuitive video for you. And I will regularly make such kind of POTD discussions for you. So please hit the like and subscribe button. Thank you for watching my video.